Hello my dear students, how are you? I think you all are fine. My dear students, today I am starting very important topic which is vector. ठीक है. But before the topic vector, you should know about the physical quantities. What do you mean by physical quantities in the science, in the physics subject? ठीक है. Okay, now the physical quantities are the quantities which can be measured, like your weight, your mass, weight are the physical quantities. Speed, you are riding a bicycle or bike, its velocity is also a physical quantity. I mean to say every physical quantities should be measured or must be measured. Okay, and we are measuring the physical quantities to explain the laws of physics, to explain the laws of science. Like we are talking about the force. Okay, force is a physical quantity and it can be measured, and by this physical quantity we can explain the laws of science, the laws of physics. Okay, so definition of physical quantities will be the quantities which can be measured and are used to explain the laws of physics, or the laws of science. Okay, we are studying physics, so I write physics. Okay, now my dear students, all the physical quantities are divided into two parts. Okay, all the physical quantities are divided into the two parts. First is scalar physical quantity, okay, and second is vector physical quantity. Okay, now this partition is done on the basis of value and direction. Okay, some physical quantities need only value, like your weight. I ask you what is your weight, you say that it's 60 kg, and this 60 kg is just only a value, not direction. Okay, and you don't say that my weight is 40 kg towards the north, towards the south, towards the east, towards the west. Okay, then it means to define mass, we need only value, we don't require direction. Okay, we don't require direction. Okay, so we say scalar physical quantities are the quantities which has only value, not direction. Okay, like mass, like temperature. Okay, just say for example I ask you what is the temperature of your area, you tell me that it's 40 degrees Celsius, then 40 degrees Celsius is just a value, not showing the direction. You don't say that it's 40 degrees Celsius towards the north, towards the east. Okay, so I want to say that some physical quantities like mass, temperature, time, current, okay, these physical quantities are defined by their only value, not by their directions. Okay, first thing. Now second thing is vector physical quantities. the physical quantities, you had to write in your notebook the physical quantities which have value, which has value as well as direction, as well as direction. For example, this marker is an object. Okay, this object is placed on the surface. Now you apply a force on it like this or like this. Okay, so the this force has direction also. This applied force has direction also. Okay, so some physical quantities in our physics subject need direction, so that physical quantities are known as vector. For example, force F is a vector quantity. Okay, and acceleration, accelerate, you are accelerating your car, you are accelerating your bike, okay, in a certain direction, so acceleration is also a vector physical quantity. Okay, so write the definition in your notebook. The physical quantities which require value as well as direction are known as vector physical quantities, like force, acceleration, etc. Momentum भी होता है, it is momentum also. Okay, and further we are going on the syllabus, and in the next video lectures there are many physical quantities. Some will be scalar, some will be vector. Okay, for this time you keep in your mind that the vector physical quantities has value and direction. Okay, now today topic is vector, which is very important, because normal scalar physical quantities are added normally, like mass of this object, let is m1 equal to 50 gram. Okay, the mass of this object is 50 gram. Okay, and mass of this object, let it is m2, it is 60 gram. Okay, and what will be the total mass? M equal to m1 plus m2, then they will be added simply, by normal mathematics, or normal algebra. Okay, so all the scalar physical quantities are performed by using algebraic rules of mathematics, but we have made some rules for the vector physical quantities. Okay, dear, after the differentiating between scalar physical quantity and vector physical quantity, we will discuss about the rules of vector algebra. Okay, it means how we represent the vectors, how we will add the vectors. Okay, everything. Now, first rule about the vector algebra. In the first rule, my dear students, we learn how to represent the vector. For example, force is a vector physical quantity. Okay, so force is written as F and we draw arrow on it. It means this pattern is used to represent the vector, and it is said to as force vector or vector force. Okay, it is called as vector force or force vector. Okay, there is no major difference between the pronunciation. Okay, now, and if we use bold letter, then this symbol is also show the vector, like acceleration. For example, we take acceleration. Acceleration is a vector physical quantity. Okay, and its symbol is A, and we draw arrow. Okay, then we can bold it also. bold it also, then this bold letter will show vector representation. Okay, indirectly I mean to say that any physical quantity is represented by arrow or by using bold letter. Okay, and graphically and graphically we represent any vector by using arrow. Let's suppose a person is at point O, and he is moving towards the east direction and reaches at point A, then we draw arrow from O to A, where O is the initial position and A is the final position. Okay, then this arrow will represent the graphical representation of vector, where this point is known as tail. Okay, tail of the vector. Okay, tail of the arrow. Okay, now, and this point A will show head of the arrow or head of the vector. Okay, it is the mathematical expression of vector and it is a graphical representation of vector. Okay, and if this point is O, then we write OA vector. First letter shows initial position, second letter shows final position, and we draw arrow on them. Okay, now rule number 2. We have three symbols. Four directions. In the mathematics you have learned about that length, height and breadth is along the axis x, y and z respectively. Okay, let we have a cubic structure like this copy has length, okay, height and breadth. So then this configuration is known as three-dimensional configuration. It is a 3D system, axis x, y and z. Axis y is along the height, axis x along the length, or axis z is along the breadth. Okay, it is a 3D system. Okay, now in the mathematics you have learned that the values on the axis x is represented by small x, because this axis is capital X. Then we write x comma 0 because the value of y and z on this axis is 0. Now the value on the axis y is always small y, where x should be 0 and z should be 0. So the coordinate on the y axis 0 y 0. Now on the z axis every point has three coordinate, where z represent the coordinate on the axis z, and x should be 0 and y should be 0. So the coordinate becomes 0 z. Okay, now in the mathematics x, y, z are the values like coordinate system 2 0 0 0 1 0 0. Okay, it is the overview of mathematics. Okay, now it is applicable in vector form. How? We know that every vector quantity has value as well as direction. Okay, now value on the axis x, value along the axis x is represented by small x, and the direction symbol is I cap. Okay, the I cap symbol shows the direction along the axis x. So we write x I cap. For example, assume that this marker is placed right now in this position. Okay, and I am applying force on it. Along the axis x. then the direction of along the axis x is represented by the I cap and value will be x. Now for example, a lift is lifting upward, a lift is vertically upward, okay, then the value is will be shown by small y, small y and y is the value and direction will be j cap. Okay, I mean to say, my dear friends, I mean to say that we have three symbols, I cap, j cap and k cap. These symbols are known as unit vectors, and these symbols are used to show the directions, okay, in which I cap will show the along the axis x, j cap will show the along the axis y and k cap will be shown along the axis z. Okay, now we write y j cap and z k cap and we add all the things, okay. One more example I will take, okay. Let on an object we apply a force, on an object we apply a force, then that force is represented by f vector, okay. Now this pattern of vector is fxi cap, fyj cap and fz k cap, okay, where fx equal to, it is the component of x, component of force along axis x, and fy is component of force along y axis, okay, and fz component of force along the axis z, okay. Now we can show this expression in the graph also, let we have a three-dimensional system, axis x, axis y and z will be outward and we show by this arrow, it will be z axis, okay, and it is the origin. Now assume that an object is set here, okay, and we apply force on it along the axis x, okay, and this object will transfer from this point to point this, okay. So we show the arrow like that, let assume that is this point is a, okay, and the coordinate of this point is x comma 0 comma 0 in the mathematics, but in the vector form it is written as fx, fx is the component of force, value of force along the axis x. Assume that an object is at here again and we apply force on it vertically upward and this object is reaches to point b, then we draw arrow from o to b, and o to b, the value of ob is fy, okay, and coordinate will be 0 comma fy comma 0. Now assume that an object is here again and we displace it towards the axis z, along the axis z, and this object reaches from point O to point C where coordinate will be 0 comma 0 and fz, okay. There is some similarity of the mathematics coordinate system with the vectors, okay. These are the values and these shows the directions, okay. I cap is along the axis x, j cap is along the axis y and z is the along the axis, okay, k cap, okay. Now for example we take f vector equal to 3i cap plus 4j cap plus 6k cap Newton, okay. For example we take F vector force is 3 I cap plus 4 j cap plus 6 k cap. It means, my dear students, it means the value of fx will be 3, the value of fy will be 4, and the value of fz will be 6. Okay, these are the components of the force in three-dimensional system. In three-dimensional system where axis x this, y and z. Okay, now please note down this pattern in your notebook, okay, because it is useful for the next rows. Okay, now rule number 3rd, my dear students, rule number 3rd is related to find out the magnitude of vector. Rule number 3rd is related to the find out the magnitude of the force. If force vector is represented by this expression, then magnitude of force, is given by modulus of the vector. Modulus means this vector is represented between two parallel lines, and its formula, and it is just formula that we take square of this component and add them and take square root, like that this fx, so we take square of fx, it is fy, then we take square of fy, and it is fz, then we take square of fz. Okay, and now we take square root of all these terms. Then this formula represent how we find out value of the force. Value means magnitude. Okay, these are the synonyms. Okay, for example, a car is moving with velocity v vector equal to 3 I cap plus 4 j cap plus 1 k cap meter per second. Okay, and in question, value of velocity, it means magnitude of velocity is asked, ये पूछा गया था. Okay, now answer. Okay dear, ध्यान दीजिए, be considered here. Velocity is given in this pattern is matched to this pattern, and formula of magnitude will be represented by the modulus means two parallel lines. Okay, now according to formula, this formula showing the squares of component, so these components are 3 4 1. Okay, so 3 का square, 4 का square and 1 square and all over square root, then they I will be added. Then 9 16 plus 1 equal to me 1. Okay, 69 25 plus 1 26, root में 26, unit is meter per second. Okay, but okay my dear students, it is the expression of velocity in the three-dimensional system in the air medium, and this show the value of velocity of the object, that is difference between v vector and modulus of v vector. Okay, got my point? It is the rule number 3rd, don't forget that. Okay, now it is take your pen copy and write it. Okay, rule number 3rd. Okay, now